Hey everyone, in today's video I'm going to go over building this carbon fiber tail fork. This is part of a multi-series project of replacing my tail wheel. I need something a little bit beefier. And I thought, hey, it'd be really fun to build one. But first and foremost, before we start the video, I want to take this moment to give praise and glory to our Lord Jesus Christ, who is King Almighty. All glory and praise go to Him, and we should always remember that in everything that we do. So with that, let's jump right into the video and let's build a tail fork. One of the most important things you can do when laying up composites is have everything laid out on a clean table so that it's easy, it's accessible, it's ready to go. Here I have both my fiberglass and my carbon fiber already cut out. Gloves, extra pair of gloves, scissors, tape, Sharpie, scales in case you need them. The resin, acetone for cleanup, stir sticks and cups. The wax, which is used for the molds. I've been laying up PVA coating inside the molds. This is a really good mold release agent. If you guys look at the mold, part of the mold prep, on all my flat surfaces, I actually use packaging tape. Packaging tape makes a really good release. It's really easy to get a part off with packaging tape. These are still going to be sacrificial one-time use molds. We'll end up probably destroying these molds to get the part out. I also have the hardware that will be going inside the layup right here, all the bushings, as well as the inserts that will go into the mold to hold the molds together. We have ready to go the vacuum system. So once the layup is completed, we'll actually vacuum bag it to squeeze out any excess resin, as well as hopefully get rid of any air. So let's start laying up and see how this part turns out.
Like the gods of old, I'm always ready for war. I'm the lightning, the thunder, the heart of the storm. I'm a rebel, I'm a devil, I'm a thief in the night. I'm moving close like a ghost, and you'll see me ignite.
Alright guys, layup's completed. We have it vacuum bagged right now. I'm inside the mold. But we'll see how it turns out when we attempt to pull it out.
Cause my powers are supernatural. With the wave of my hand, you'll see me back in the sky. Anomaly, prophecy, wanted dead or alive. I'm an outlaw, the last straw, walking the line. I'm moving close like a ghost, and you'll see me ignite. On fire like a heat wave. I'm blowing up like a grenade. A dynamite, I will explode. Cause my powers are supernatural. Supernatural. Cause my powers are supernatural. My powers are supernatural. Cause my powers are supernatural.
Alright guys, this is it. Pretty happy with it so far. There are some small pockets where wasn't able to get resin or carbon fiber or fiberglass into that appeared, some minor defects. I can go back and fill those in, but before I do that, I'm actually going to load test it first because filling those in won't add very much structural help, so it's better to load test it now rather than keep doing work on it. Well, here it is after some cleanup and with the wheel on. Wheel fits pretty good. Yeah, the only thing we have left to do now is load test it. I'm going to load test it, do a static load test to 500 pounds. The reason for that is that's the limit of this wheel. I'm going to do it with the wheel off, of course, so we don't damage the wheel. So yeah, we'll do a static load test to 500 pounds and see how it does. When we do a static test, a 500-pound static test on this wheel, we'll hopefully simulate essentially a 3.3G landing on the tail wheel, which is, in landing terms, that's a very hard landing. All right, guys, sometimes it doesn't have to look pretty to work, but this is going to be our load test jig. That being 6 inches away, that means that we can apply a much smaller load on this end, so that blue painter's tape right here is 60 inches from the fulcrum, which means we'll only need to apply 50 pounds on there to get a force of 500 pounds right here. Kind of cool, a lot less dangerous, and if it breaks, well, we'll won't have 500 pounds coming down on us. If everything's set up, ready to start loading. Guys, that's 500 pounds loaded up right now. Tailwheel looks great. Strain looks really good. Tailwheel hasn't moved it very much. Obviously no signs of cracking. When I take it off, I'm going to test look at all the hardware, make sure nothing's moved out of place, nothing's failed internally as far as the hardware goes. But as of right now, that's a pass tailwheel fork, so I'm pretty excited. Now I got to get the rest of the suspension built. Originally, the fork was to be made from 3/16 4130 steel. Found this would be a pretty difficult bend to perform. Additionally, 4130, even if powder coated, would be susceptible to corrosion as the fork is exposed to extreme elements, being on the back of the aircraft. That's when I thought, why not make it out of composites? I cannot find anyone who's made a tail fork from carbon fiber, likely because carbon fiber is actually pretty brittle and would be susceptible to cracking with rocks and debris hitting it. An engineering approach to this is to use fiberglass in the laminate with the carbon fiber, as fiberglass can withstand impacts much better than carbon fiber, even though it lacks in the stiffness that carbon fiber provides. I'm also trying to come up with a stainless steel or titanium leading edge, but acts similar to a leading edge of a turbofan blade. To calculate how much my tail fork costs, I use the volume to calculate how much fiber and resin I would need. Once I had the weight of the fiber, I was able to determine how much carbon fiber I would use and how much fiberglass I would use. This was then easy to calculate what the actual cost in carbon and fiberglass would be. For the same amount of fiber, you can see the price difference between the carbon and the fiberglass, which explains why carbon fiber is always more expensive than fiberglass. Additionally, I added in the hardware used in the TailFork. Now this is my final cost for the tailwheel itself. This doesn't include my time, which was quite a bit, as well as the other materials used for mold prep, making the mold, and the vacuum bagging materials. But overall, I'm pretty happy with that cost, as a tailwheel that off the market would cost anywhere between $200 and $2,000.